All right, let's talk about Terraform. In the next few minutes, we're going to totally demystify this tool. We'll break down exactly how it lets you build your entire cloud setup using nothing but simple code. Let's get right into it.
So does this sound familiar? You're clicking through endless web consoles, setting up servers, networks, databases, just kind of hoping you got all the settings right. You know, that constant worry that your dev environment is just a little bit different from production and it's just waiting to cause a massive headache late on a Friday night? Yeah, if you're nodding along, you are in exactly the right place.
So let's start by really digging into the problem we're trying to solve here. We'll call this Section 1, the manual infrastructure problem. This is all about those endless clicks, the inconsistencies they create, and this really sneaky thing called configuration drift. And here's the thing, these problems, they all feed into each other. You know, manually setting up a dev environment, then a staging one, then production. It's not just slow, it's basically a recipe for disaster. All it takes is one person making one tiny, undocumented change directly in the staging console, that's configuration drift, and bam, your code, which worked perfectly fine everywhere else, suddenly dies in production. And scaling? Forget about it. It becomes this frantic manual scramble instead of a calm, automated process.
The solution to this chaos is a huge shift in thinking. Infrastructure as code, or IAC. And as you can see from this comparison, the difference is night and day. We go from this murky tribal knowledge that's just stuck in someone's head to a crystal clear blueprint that's documented right there in the code. We trade fragile, inconsistent environments for rock-solid, reproducible stability. Ultimately, this means you can ship new features way faster and deal with way fewer outages. Your infrastructure becomes just as reliable and version-controlled as your application code itself.
Okay, so how do we make this whole infrastructure as code dream a reality? Well, that brings us to Section 2. Where we introduce the hero of our story, Terraform.
So what is Terraform at its core? It's a tool that lets you write these simple, easy-to-read configuration files. In these files, you just describe the cloud stuff you want, your servers, your databases, your networks, and Terraform handles the rest. It does all the heavy lifting to build it for you, and it does it safely and super efficiently.
The best way to think about it is like this. Your Terraform code is the detailed architectural blueprint for a skyscraper. Terraform is the automated construction crew. It reads that blueprint and builds the skyscraper perfectly, exactly to spec, every single time. You write the plan, Terraform builds the reality. Simple as that.
Okay, that sounds great in theory, but what's it actually like to use day to day? That brings us to Section 3, Terraform's core workflow. This is the simple, repeatable rhythm you're going to use on every single project.
Conceptually, it's just 5 simple steps. First, you download the tools you need for your cloud. Then, you check your code for any obvious typos. And then, and this is the magic part, you get a full preview, a plan of exactly what Terraform is about to do. Only after you look at that plan and say, yep, that looks right, does Terraform actually go and build anything. And when you're all done, a single command cleans everything up.
And right here, you can see how those concepts map directly to 5 core commands you'll type all the time. Terraform init to download, validate to check, plan to preview, apply to build, and destroy to tear it all down. This simple, powerful workflow is really the heart of why Terraform is so safe and predictable.
All right, so we get the process. But what does the code, the blueprint itself, actually look like? Let's dive into that in Section 4, Building with Blocks.
Now, the language might look a little intimidating at first glance, but here's the secret. Pretty much everything you will ever write in Terraform is built from just 3 foundational types of blocks. That's it, just 3.
First up, you've got the Terraform block. Think of this as the main settings block. It's where you tell Terraform things like which version you're using and which cloud providers, like AWS or Google Cloud, you're planning to connect to.
Next up is the provider block. This one configures the connection to that cloud. It's where you'll specify which cloud region you want to build in and how Terraform should authenticate to get access.
And finally, the real workhorse, the resource block. This is where you describe the actual stuff you want to build, an EC2 server, a virtual network, a database, you name it. This is the most important block you'll use, hands down.
So how do you actually talk to these resources? Well, it breaks down into 3 things. Arguments are the inputs. They're the settings you provide, like telling a server you want an instance type of t2.micro. Attributes are the outputs. They're values the resource gives back to you after it's created, like its public IP address. And then you have meta arguments, which control behavior, like telling Terraform, hey, I need you to create 3 of these identical servers.
Okay, this is all fantastic for a solo project on your laptop, but what happens when you've got a whole team managing a global fleet of servers? Let's jump into Section 5 and see how Terraform scales for big, collaborative environments.
So, the single most crucial thing for teams is understanding something called the state file. By default, it just lives on your computer, which is a huge, huge problem. Why? Because if you and a coworker both run Terraform apply at the same time, you're going to break everything. The solution is called remote state. Storing that state file in a shared, secure place like an S3 bucket with locking enabled is completely non-negotiable for any serious team. It prevents conflicts and makes sure everyone is working from the same single source of truth.
Now, the second key to scaling and collaboration is a concept called modules. And honestly, the best way to think about them is as reusable, shareable Lego bricks for your infrastructure.
Instead of writing out all the code for, say, a complex and secure network setup every single time you need one, you define it just once inside a module. Then, anyone on your team can just grab that perfect, pre-approved network brick and use it anywhere. This makes sure everything is consistent, it hides away all the complexity, and it lets you build on the best practices of your team and the entire community.
Okay, let's do a super quick recap. First, with Terraform, your code is the blueprint. It's the single source of truth. Second, that plan before apply workflow makes every single change you make safe and predictable. Third, the language itself is just built on simple, understandable blocks. And finally, when you're working with a team, remote state and modules are the absolute keys to scaling up without chaos.
And that really brings us to the final thought. Terraform gives you the power to describe, diversion, and to automatically build literally any piece of cloud infrastructure you can imagine. So the real question isn't what you can build, it's if your entire cloud is defined in code, what couldn't you build?